Hey all, so we're here to talk about the mole. So we've been talking about the mole, and we know it's a number, much like a dozen means 12. The mole does have a number that's associated with it, but early chemists didn't actually know what that number was. They just knew it was really helpful for comparing atoms. But our next step is to figure out, well, how much is a mole? So first I want you to consider, if I were to measure out 1 mole of water in a graduated cylinder, how much water would I have to measure out? Take a second and consider that. So hopefully you're thinking, okay, water, H2O, so 2 H's and 1 oxygen. Let me add up those molar masses. It's about 18.01 grams for every mole. And then we know that the density of water is 1 gram for every mole. So 18.01 grams would be 18.01 milliliters, and you measure that out. And you can see this is a mole of water. It's about 18 milliliters of water, mole of water. So now I want you to ponder, how many atoms, or even let's say molecules, how many molecules of water do you think are in here? It's not very much water. How many molecules of water do you think could fit in there? Think order of magnitude. Is it a million, 10 to the 6? A billion, 10 to the 9? A trillion, 10 to the 12? Or even more, 10 to the what power? How many water molecules are in here? So the actual answer, if you're close, is 6.02 times 10 to the 23rd. So that's 6.02 with 21 zeros after it. Take a second if you want, write that number out. 602 and 21 zeros after it. I don't even know what number that is. I don't even know what the name of that number is because it's so big. That many water molecules in here. Wow. Molecules are really, really small. So that number has a name. It's Avogadro's number is what it's called. So let's actually write that out here really quickly so we remember it. So Avogadro's number, really important number in chemistry, 6.02 times 10 to the 23rd. And that's how many particles are in a mole. And that could be anything. That's not specific to a certain type of atom. I mean, it could be 6.02 times 10 to the 23rd cookies in a mole. Wouldn't that be great? If you had that many cookies, you'd be pretty happy. Remember, it's just a number. The mole is just a number. We say a dozen, it means 12. We say mole, it means 6.02 times 10 to the 23rd. It's just a little bit bigger. So let's practice converting between particles and moles. So we're going to start here with a 4.07 mole sample of sodium iodide. And it's asking how many atoms of sodium does it contain. So first I'm going to need to find how many compounds, because I have this many moles of sodium iodide, so I need to figure out how many sodium iodide. So I have those particles. But the good news is, for every 1 sodium iodide, there's 1 sodium atom. So it's going to be the same. However many sodium iodides I have is how many sodiums I have, because there's a 1-to-1 ratio here. So that makes it easy. Now, the nice thing when I'm going from moles to particles, I don't need my periodic table, because again, a mole is just a number. It doesn't matter what you have. It doesn't matter what element it is. It's just a number. So I don't need my periodic table. I know that 1 mole is 6.02 times 10 to the 23rd particles. And like we've been doing with our algebra, we're just going to cross multiply. So bottom times top equals bottom times top. Remember that, your equal sign. And if we do that math, you do need to pay attention to scientific notation here. I do 4.07 times 6.02 times 10 to the 23rd. And to 3 sig figs, I get x equals 2.3 sig figs, 45 times 10 to the 24th sodium atoms. That's what I'm looking for, sodium atoms. Notice how I don't leave out that scientific notation, and you might see that scientific notation as E to the 24 in your calculator. Know that that means the same thing as 10 to the 24. So if your calculator says E to the 24, it means the same thing as 10 to the 24. So just keep your eye out for that. And that's how we go from moles to particles. So let's try it the other way. It says how many molecules of iron 3 chloride are there in 16.5 times 10 to the 25th molecules of iron 3 chloride. And this should actually say moles. How many moles do we have? So I have molecules. I'm looking for moles. Well, remember, it's going to flip because I'm doing the opposite thing, but I've got 6.02 times 10 to the 23rd molecules for every 1 mole. And I know that goes on top now because it's an equal sign. Moles equals moles, molecules equals molecules. Now, like usual, when I do this algebra, this is going to be a little more complicated because I'm going to end up with 6.02 times 23rd x equals 16.5 times 10 to the 25th molecules. So remember, we do cross, cross. So I get 16.5 times 10 to the 25th equals 6.02 times 10 to the 23rd x, which means I'm going to have to divide both sides by 6.02 times 10 to the 23rd. Here's my advice. When you put these in your calculator, use parentheses. If you don't, you might get some crazy number like times 10 to the 46th power. If you get that, you know you forgot parentheses. So when in doubt, use parentheses, especially in the denominator, because your calculator can't read your mind. You have to be smarter than your calculator, and you have to tell it the order of operations, because otherwise it's going to do 16.5 times 10 to the 25th divided by 6.02, and then it's going to multiply that by 10 to the 25th. But that's not the same thing, so put it in parentheses. Change the color here so we can see it. So I get x equals, 3 sig figs, 274 moles. And that makes sense because I've got 10 to the 25th divided by 10 to the 23rd. Remember, we subtract exponents when it's division, so that gives me 10 to the 2nd. So we should be on the order of magnitude here of 100, which 274, I am. So that checks out. You're on the order of magnitude of 10 to the 48th. Go back, put your denominator in parentheses. That's where you messed up. So you need to watch those exponents and make sure your end answer makes sense. But that's how you convert between moles and particles. Remember, you don't need your periodic table. All you need is Avogadro's number, 6.02 times 10 to the 23rd particles for every mole.